A very good day to Dr. Jong. Firstly, let me introduce myself. I'm Jivashini Balasundram. My matrix number is CE230142. Today, we would like to present about Fourier series. About explain any details, let me do an introduction about what is Fourier series. So, for the introduction, the Fourier series is a fundamental mathematical technique that allows for the decomposition of periodical function into a sum of simple sine and cosine component. Developed by Jean-Baptiste Joseph Fourier in the early 19th century, this approach provides a powerful framework for analyzing and representing complex periodical phenomena. At its core, the Fourier series expresses any periodical function is as an infinite sum of sine and cosine, each with specific coefficient that dictate their amplitude and phase. These coefficients are derived through integrals over one period of the function, capturing the essence of the function's behavior over its cycle. The ability of the Fourier series to transform a complex waveform into constant consistent frequencies make it invaluable across various fields, including signal processing, heat transfer, and vibration analysis. For instance, in signal processing, Fourier series facilitated the breakdown of signal into their frequency component, adding in tasks such as filtering and compression. Similarly, in heat transfer, the serial can model the distribution of heat over time in a given medium, providing critical insight into thermodynamic. The convergence properties of Fourier series ensure that the reconstructed function closely approximate the original, particularly at point of continuity. This mathematical tool not to enhance our understanding of a periodical function, but also underpin underpins many practical applications in science and engineering, making it an essential concept in both theoretical and applied mathematics. Fourier series are mathematical equations applied in analyzing and processing of periodic signal in terms of sine and cosine function. It provides the possibility of representing any periodic function, numbers and their sum, which is a periodical function is an infinite sum of sinusoidal function with different periods. The Fourier series is applicable in establish an understanding of periodic message by decompressing them in crits part. Supposing the sine and cosine term in any serial carry, the one can be able to identify the coefficient of the sine and cosine term in a series, which in turn enable one of the reconstruct the original periodic function. These mathematical tools find wide application in various fields like signal processing, telecommunication, physics, and engineering, where uh, high throughput or characteristics signal it's most important to identify the frequency component of a series. So as for the methodology for analyzing period function involves several key steps: finding the angle and the amplitude periodic function, so deriving the Fourier coefficient, and to represent the Fourier series of the given signal to approximate the original function, calculating the continuous Fourier transform, employing equation to obtain the frequency representation. So Fourier transform using MATLAB built-in function like FFT, and lastly, in this case again we will plot and compare the original function. The Fourier series approximation of the function and the filter signal to compare the advantage of the Fourier series approximation in approximating the function, determining the frequency component proportional to the area under the curve using the Fourier transform, and assess the effectiveness and of the low-pass filter in preserving certain signal characteristics and editing others.
Selamat sejahtera Doktor, my name is Muhammad Afiq bin Safawi and my majors number is CE230060. So today I will be presenting the project for the question 1 and 2. So for question 1 consists of 3, which is pre-project 1, 2 and 3. So this one for the coding pre-project 1. So the first one coding here is to define the signal parameter. So the parameters is T naught, tau and T. Next, this is coding for the define the Fourier series coefficient. Next, this is the calculation, the signal for the specific harmonic. Next, we can sum of all the signals, then plotting the results, then plot the sum of all the signals. So the signal should be like this. So for the part Cy, which is for xt, for the part Cx is time, which is this signal called time domain. So this for harmonic 1, 2, 3, and sum of the 3 signal. Okay, next for the pre-project 2, just show the signal. So this one, the signal for the pre-project 2. Next for pre-project 3. Pre-project 3, we get the signal. Magnitude of xn, magnitude of h, cy is xn, equal to number of n. Here, so define the signal filter parameters, compute Fourier series coefficient, then putting the result, define the frequency response of the low pass filter. Okay, tak ada. Alright. Next is question 2. For question 2, first of all, we need to manual calculation, which is to find the tau. So T naught, to find T naught is 1 over F naught. So F naught given to the by the attachment 1, which is F naught is 280 kHz. So when inside the formula, we get T naught equal to 3.57 micro S. For the tau, we get 1.78 micro. So for the analysis, which is the figure we get is this. So this one for the frequency domain, which is for 5 harmonics, 10 harmonics, and 20 harmonics. So the part C, X and Y is magnitude, X is frequency, M hertz, megahertz. So for the time domain, this signal. For amplitude, times in micro S. So for the coding, here is to define the signal parameter, define time vector, number of cycle, which is how many cycle for the like 10 cycle 10, 10 cycle about the signal. So apa lagi nak explaining. So this one to coding for the frequency domain analysis. This one should be compute Fourier series coefficient. So we're going to start the signal and using n harmonic. So that's all for the analysis. Time domain show how the signal improve in the approximation with increasing harmonics. Signal reconstructed with more harmonics is closer to the original waveform. For frequency domain, provides insight into the harmonic content of the signal. The magnitude of the Fourier coefficient decrease with increased harmonic number, and significant evolution is concentrated in the lower harmonic for square wave with 15% duty cycle. That's all for me.
My name is Vanilla Subramaniam, and here is the construct of a low pass filter using MATLAB. And I used this coding using the previous pre-project coding. Since we are group number 3, we had used this value, which is 280 kHz and also 1030 kHz. From this, we had learned about frequency domain analysis and also time domain analysis. So the frequency domain analysis is explained that it's a response plot shows how the filter attenuates different frequency components with the gain in dB is plotted against the frequency. Other than that, the time domain plot shows the input signal containing both flow and high frequency components, and the output signal after filtering. The low pass filter should attenuate the high frequency components and pass the low frequency components. And that's it from my part, doctor. Thank you.
Good evening, Doctor. So there, I'm Putra Hamizan bin Kamarizal, our matrix CA230020. Today I'm gonna explain about question 5. So the question is, construct a circle representing the low pass filter in your built-in task tree. Pass your signal as the input to that filter. Analyze the output of the filter by comparing its output with the simulation and discuss your result. Okay, so for question 5, we have given for our group is group 3. So for our F naught is 280 kilohertz and my FC is 1030 kilohertz. So the formula for FC is 1 over 2 pi RC, and R is 1 over 2 pi FC and C. So assume that the value of C is, we choose 40 picofarad. So the formula 1 over 2 pi times with 1030K times with 40p, and then we got 3862.98 ohms, just like this. So in this is the simulation. So this is the value that we got earlier, 3.3862.98 ohm. So we are and this we're using capacitor 40 picofarads. So you can see that we got the frequency response here, this triangle and then the phase. So for so for question 6, investigates the effects of the having a lower and higher duty cycle. Set the duty cycle for the case of tau 10%, 20, 30, 70, and 80. Okay, for this part we had to calculate for every duty cycle, which is for tau 10%, 20%, 30%, 70%, and 80%. Besides that, based on the question 2, we have calculates from the value of tau for 50%. So to get the value for 100%, we need to calculate the value. So we got the value from our, this is 1.79 micro times by 2 is 3.52 micro. So this is for cycle 100%. So we can see here's the codings. So the time is 1 over 280. The value that I've given to our group 280 kilohertz. So the tau here is 2.856 micro. I think it's this for 80%. Okay, this is for 80%. So we can run this. So we got this signal result for frequency domain, and this is for time domains for 80%. So if we want the 10%, we can just take this value, the final value, and then we need to change the tau value here. And then we run with it. So this is the 10% value, signal value for frequency domain, and this is a 10% signal value for time domain. So the rest 20%, 30%, you just take the final answer that we calculated here, and we change the value from tau here to get the result. Okay, that's all from me. Thank you.
My name is Ryan Ronaldo Gispin with the matrix number of CE220055. Explaining about equation number 7, identify suitable value for both resistor and capacitor. Construct the circuit and show the analysis in 4, 5, and 6 is valid using suitable simulation software. In this lab, we assume the resistor is 10 kilo ohm and Fc is the value given by the lecturer is 1030 kHz, while FO 280 kHz is the value given by the lecturer. This is the manual calculation that are using the formula of Fc equal to 1 over 2 pi Rc. And this is the final value that I get for C is 1.1191 picofarad. This is the circuit that are construct for this question, and this is the frequency response. This is the digital oscilloscope. Now I will be the simulation using Proteus. I see now the simulation is already run, and this value is already changing, and this is the frequency response getting from the circuit. For the oscilloscope, by taking this, we can adjust here to check the adjuster, and also here for the speed of this. And thank you.
So, as for the conclusion, although the notion of Fourier series can be concluded as a highly effective mathematical instrument that effectually decompose function with periodical properties into components that can be evaluated by trigonometry function. To represent a function as the sum of sine and cosine function with defined coefficient and infinite numbers of terms, Fourier has proposed what is now known as a Fourier series because this formula provides the capability of approximating the actual function with a high degree of precision, especially at this point of continuity. This technique is, however, vital for a number of applications in signal processing, heat transfer analysis, and vibration engineering, to name but a few, as it helped to give insight into a periodical behavior of system. The importance of frequency component of periodical function and their usage in both theoretical and practical mathematics cannot be overstated because they underline the effectiveness of Fourier series. Real-world application made possible by MATLAB and similar tools make it possible to cover analysis and signal processing, system modeling, and using Fourier series as efficient noise elimination tools, proving the relevance of Fourier series even today.